Alright, it feels like it's been a long time since I've done one of these, and this lesson over molar conversions part 2 is brought to you by Energy Rush. Feel the energy. So, for molar conversions part 2, what we are doing is we're not going just from moles to particles, particles to moles, mass to moles, or moles to mass. This time, we're going to go from particles to mass or mass to particles. Now remember, for particles, that can mean anything like atoms, compounds, molecules, ions, etc. You can ignore the story time. You probably should have seen that video earlier, which I think was the last video. But basically all it talked about was how you can never go directly from mass to particles. You can never go directly from particles to mass. You always have to change it to moles first. Alright, so this first example, let's go from mass to particles. Since you can never go directly from mass to particles, I'm going to show how you have to go to moles first. You always go to moles first. So in this case, I'm going to start with mass. That's what you start with. I need to change it to moles. You always change things to moles first, and then I can change it to particles. So what you're going to find out is I'm going to divide first by mass, and then when I get my moles, I'm going to multiply it and change it to particles. So let me show you. Basically, here's what the equation breaks down into. I'm going to give you a mass right here. Then you need to change it to moles. Remember, one of the most important things is writing down where things go that you need and where things go that you have to get rid of. I want to get rid of mass, so I'm going to put mass at the bottom, specifically the molar mass. I need mole, so I'm going to put mole on top. The problem is my answer then will be in moles, but I don't want moles. So what I have to do next is I have to convert it again. This time, I'm going to put the mole on the bottom, and I'm going to put the particles on top, Avogadro's number. So again, all you're going to do is I will give you a mass, you will divide it by molar mass, and then you'll times it by 6.02 times 10 to the 23. And that will give you your answer. For example, find the number of particles in 17.2 grams of H2O, of water. So again, find the number of particles. This is, I'm trying to find particles, and I started with mass. So this is a mass of particles. So, oops, showed too much there. So for this one, you would write down the number you start with, 17.2 grams of H2O. I need to change that to moles first. So when I do that, I'll put 1 mole on top. That will change it to moles of water. I'll put the molar mass of water on the bottom. And that will give me an answer in moles. Do not round. Do not round in the middle. Do not do that. You're going to keep that number in your calculator. Next, I go, okay, that gives me my answer in moles, but I don't want moles. I need to change it to particles. So I take my number that I just got on my calculator, and this hit times 6.02 times 10 to the 23. So literally I do 17.2 divided by 18.02, so that's the mass given divided by the molar mass, then times Avogadro's number, 6.02 times 10 to the 23. Next, I have my answer, but the big thing are sig figs. 17.2 is 3 sig figs, 18.02 is 4 sig figs, 6.02 is a constant, don't worry about that. These ones are constants, don't worry about that. So it's either between 3 sig figs or 4 sig figs. Since I'm multiplying and dividing, I use the fewest number of sig figs, so that would be 3. So my answer must have 3 sig figs. So when I round my answer to 3 sig figs, I get 5.74 times 10 to the 23 particles of H2O. Again, all I do is I take the mass given, divided by the molar mass. That will give me moles, but I don't want moles. I need particles. So then I get rid of moles by putting a mole on the bottom and putting the particles on top. Now, some of you may see the shortcut in this, but don't worry about the shortcut. Don't use the shortcut because technically you're not supposed to use the shortcut. The main thing is you can never go from mass to particles in one move. You have to change it to moles first. If I go the other way, this would be particles to mass. Well, in this case, I have to go to moles first. So again, I'm going to start with particles. I'm going to divide by Avogadro's number to get moles, then multiply by the molar mass. And you're going to see an example of that right here. So with this, I will give you particles. I will give you a number. I'm going to change it to moles by putting the mole on top, because that's what I want to start with. And I'm going to put Avogadro's number on the bottom. That will get rid of particles and give me moles. But again, that's only halfway there. Then I have to get rid of moles. So I'll put mole on the bottom and I'll put the molar mass on top. So I will divide by 6.02 times 10 to the 23, and then I'll multiply by the molar mass and that'll give me my answer. For example, calculate the mass of 1.09 times 10 to the 27 particles of calcium hydroxide. Again, calculate the mass. So I'm trying to find mass, and what did I start with? I started with particles. Again, your guys' questions probably will say compounds or molecules, something to that effect. But this is a particle to mass situation. That tells me right away 2 steps. I have to find moles first. So this is particles, change it to moles, then I can change it to mass. Step 1, like always, write down what I give you. I have 1.09 times 10 to the 27 particles of calcium hydroxide. Then what I need to do is change it to moles. So I'll put the mole on top and the Avogadro's number on the bottom. But again, that will give me an answer in moles. I don't want moles, that's halfway there. I need to change it now to mass. Well, to get rid of the mole, I'll put the mole on the bottom this time and the molar mass of calcium hydroxide on top. So the molar mass of CaOH(2) is 74.10. I multiply all that out, and that is nowhere near the right answer because of sig figs. I have 3 sig figs here. These are constants, 4 sig figs, so I need 3. Usually it's always 3. And that would be 3 sig figs. There we go. 134,000 grams of calcium hydroxide. And that is how you go from moles to particles and particles to moles. Perfect timing.